it's Mrs. Glenn. Welcome to 1.2, Distributive, Commutative, and Associative Property. In this lesson, you will understand how to identify and apply the distributive, commutative, and associative properties when given certain expressions. So first, we're going to start out with the distributive property, and that states if A and B are real numbers, then A times B plus C equals, so all you do is you multiply A times B, then A times C, and you would write that in your lines. It would be A times B and A times C, and you would get your answer. Another way to visualize it is if you're multiplying two binomials together, you can separate those binomials into a box method where you have A and 4 there, which is the first parentheses. We just took the A and the 4 here. And if there was a minus sign or a negative A, we would make sure we put that there because we want to include it. But these two are positive, so we didn't put any signs in front. And then your A and your 5 are just going to go on the row side. So A and 4 are your columns, and A and 5 are your rows. And then all you do is you multiply, just like when you were in elementary school and you were trying to do the multiplication tables. You were probably given a big sheet of multiplication tables, but you would just match them up. You would go one finger here and one finger here, and when you would draw your fingers together, this would be where the answer is. Same thing. So A times A would equal A squared. And then A times 4 would equal 4A. And 5 times A would equal 5A. And 5 times 4 would equal 20. And these diagonals will always match up because you've done that in that order, as long as you have them listed like we do where the A is here and A is here. In this problem where the first number or letter starts here, then these two will always be like terms. If they're not, then you just have to look for the ones that are. But 5A and 4A are like terms, so you can combine them together to get 9A, and you would just write that in standard form. So you have A squared plus 9A, and then the 20 is left over, and that would be your answer for that trinomial. And that would be how you would use the distributive property to solve that. Then we have commutative property. So the order of the numbers can be rearranged without affecting the sum or the product. So let's take a look at an example. So if you have A and B are real numbers, then A plus B can also be B plus A, and A times B can also be B times A. So you can flip-flop them and rearrange them as long as they're adding or multiplying. It does not affect the answer for the sum or the product. Then associative property, the order of the numbers does not change, but the grouping is what changes. So the grouping of the numbers can change and does not affect the sum or the product. So down here, let's take a look at the order of an example. We have if A, B, and C are real numbers, then A plus B plus C could also be A plus B plus C. So instead of having the parentheses around A and B, we just moved it to having the parentheses around B and C. Now the bottom here, instead of it being AB times C, we can have A times BC. So you just move the parentheses over, and we're going to take a look at why you do that later on. You're probably wondering what's the point, but when you get to the later on problem, you're going to go, oh, okay, that makes sense. That makes the problem a lot easier to solve. So let's take a look at how you can identify which property you're using. So number 1, instead of having 12 and 8 in the parentheses, they moved it over to have 8 and 2. So they changed the grouping. So which property should that be? It would be the associative property, and it's the associative property of addition because there's plus signs. So whatever signs are in the middle, that's the property of whatever it is, addition or multiplication. Then number 2, we have 4 being distributed or being multiplied by each of the terms in the inside of the parentheses, and that's just the distributive property. Blah, 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 blah. And then number 3, instead of having 8 times 2 in the front, they moved it to be over to the right-hand side. So that's the commutative property, and they're multiplying, so it's a commutative property of multiplication. So they just changed the order. They put 8 times 2 in the front here, and they moved 8 times 2 to the right instead. So they didn't change the grouping, they changed the order. So the order would be commutative. And it's multiplying, so commutative property of multiplication. And over here, again, they just changed the order. Instead of having 5 first, they wrote 5 last. So that's the commutative property of addition this time because there are addition signs in between. Then down here, they have the grouping of -3 times 2 on the inside, but over here they have the grouping of 7 times -3. So that changed the grouping. So if it's changing the grouping, then that's associative property. And they're multiplying, so it's the associative property of multiplication. Then the last one, we have 4a plus b times 2a minus 2b. These two binomials are being multiplied with each other, and you want to distribute everything from the first to the second. So that's 4a times 2a, 4a times -2b, b times 2a, and b times -2b. You can use that box method that we did on the previous page if that makes more sense to you. It's the same setup. It just has an extra letter here at the end that we didn't have in the previous example. So that's the distributive property because you're distributing everything in the first to everything in the second. And you'll get your 4 terms, and then the 2 middle will combine to give you that -6ab for your final answer. And you would just write that as your final answer to 8a squared minus 6ab minus 2b squared. To be or not to be? Okay, that's a little cheesy. All right, moving on. Number 7, write a mathematical proof to show 2a times 4b times 5c is equivalent to 40abc. So we start out with 2a, 4b, and 5c, which is the given problem. And then you're going to use the associative property of multiplication to rearrange these so that they're in groupings together. So at the end, we'll get our answer of 40abc. So instead of having 2a being grouped together, we have a times 4. So we're just changing that parentheses to be around a times 4 instead, which then kicks the b and the 5 together to be in a parentheses, moving c out to the outside. So that's the associative property of multiplication. Then we're going to rearrange it one more time. Instead of having a first, we're going to write 4 first. And if you notice, we're shifting all of the numbers to the left, and we're trying to shift all of our letters to the right because our final answer has a number in the front and letters in the end. So that's our whole goal right now, is to try to rearrange them so that we have numbers to the left and letters to the right. So when we rearrange that, that kicks now moving over A to over one spot, and now we move B over one spot. So that is the commutative property because you are rearranging it by flipping it around. You're not changing the grouping, you're flipping it, the order of it. So then the next one is we're going to move that 4 now over with the 2. So 2 is being multiplied with 4. We're going to move the 5 over with the a times the 5. So then we have a times 5. And then now we have b times c left over at the end. And that is the associative property of multiplication. Then we're going to use commutative again one more time to shift. And we have 2 times 4 and 5 times a. So we want to flip it over so that our 5 is with the numbers. And now all of our letters together over to the right. So now we just have to group them together so that the letters are in one and the numbers are in the other. So we have 2 times 4 times 5 in one, and a times b times c in the other. So that's the associative property because we changed the grouping this time. And then we just simplify. So we have 2 times 4 times 5 is your 40, a times b times c is your abc. So that's your simplifying your answer. And that's how you do a proof, is that to the right, that's telling you what you did to get to that problem. We used associative to get to this, so we used commutative to get to this, and so on. And we simplified to get to this. So when you're asked to do a proof, you're supposed to list what property you use to get to your answer. Now last one, number 8, Grizzly Adams is having a birthday party. He needs to make goodie bags for 9 other kids who will be there. Each bag will contain 4 pieces of candy, 1 pair of glasses, and 2 temporary tattoos. Part A, write an algebraic expression. It's supposed to be N. Write an algebraic expression to represent the situation. So we have 9 bags that we're creating, and we have 4 pieces of candy. So C is going to represent candy. G is going to represent the number of glasses, and there's only 1. And T is representing the number of temporary tattoos, which we're giving them 2. So here is our algebraic expression, and we're multiplying this entire thing by 9 because we're creating 9 bags. Part B, if each piece of candy cost 25 cents, Each pair of glasses cost $4.50, and every tattoo costs 20 cents. Determine how much Mrs. Adams will spend before taxes on filling up the goodie bags for Grizzly's party. So we're going to replace C with 0.25. We're going to replace G with 4.50, and we're going to replace T with 0.20. Then you're just multiplying each of the individual ones together. Then you can use the distributive property to distribute the 9 into each of these terms, and then we'll get our answer. So we have 1, which is 4 times 0.25 equals 1. Nothing was done with the 4.50 in the middle, so we just drop it down. And 2 times 0.20 is 0.40. So you can either add them up together if you want, or distribute. It's easier to add than multiply for most students, so you can do that if you want. So if you add that together, it gets 5.90. Then you're distributing that 9 into the 5.90, giving you $53.10. And remember, this is a real-world problem, so make sure that you use the dollar sign in front. And that is the last question for these notes. Thank you for listening, and I'll see you guys tomorrow.